Episode 7 Ground Floor Slab. The episodes of building construction supervision are meant to teach anyone. Prior knowledge of building construction is not necessary. The ground floor slab transmits loads to the ground on which it rests. We will examine the ground floor slab components. I'm your tutor, Engineer Wilson Chirwa. Ground floor slab. A ground floor slab transfers loads on it to the ground. It provides an impervious layer to vertical moisture migration that would destroy finishes and encourage fungal growth. A ground floor slab is normally thinner than on upper floors because it is supported on compacted layers below it. Ground floor slab system. The ground floor slab is a system consisting of hardcore, sandbed, PVC damp-proof membrane, and concrete slab. Damp-proof membrane, or DPM, is a sheet of PVC of not less than 250 micron thickness on which the slab is cast. It is laid on the sand bed after anti-treatment poison has been applied on the sand. The DPM serves three functions: to stop water from the wet concrete of the slab from seeping into the sand and hardcore. All the water in the concrete then becomes available for the chemical reactions in the hydration process. To stop rising dampness from getting into the slab, and to allow the slab to move during hydration, reducing friction between the ground and the slab underneath. Friction between slab and ground causes cracking of the slab as it hardens. Reduction of friction assists in a reduction of cracking. Hardcore is a 150 mm thickness of well-compacted material. The material can be crushed stone, recycled broken brick, recycled broken concrete, or gravel. The hardcore is laid on a compacted leveled surface. Sandbed. A 50 mm sandbed is laid on top of the hardcore. The function of the sandbed is to cover any sharp edges of the hardcore and provide a smooth surface for damp-proof membrane. Sharp objects would puncture the damp-proof membrane and compromise its function. Floor slab. Concrete floor slab is favored because it provides an impervious layer. The slab is reinforced with mesh reinforcement placed near the top of the slab. Slab joints. Joints in the slab. There are two types of joints in the slab known as construction and expansion joints. Construction joints are discontinuities in the slab introduced to enable concrete pours to be stopped in an organized manner. The contractor can only pour a certain volume of concrete in a day. The contractor, therefore, calculates the number of bays of slab to be poured up to a construction joint. Reinforcement in the slab is continuous across a construction joint. Expansion joints are joints that allow large movements of the slab due to variation in temperature. In the cold season, the slab contracts, while in the hot season, it expands. Preventing the slab from contracting or expanding introduces significant tensile or compressive internal forces in the slab respectively. The tensile or compressive forces must be resisted by reinforcement designed for such a purpose, which can be significant. It is therefore cheaper just to allow the building to expand and contract at an expansion joint. Expansion joint features are dowels, which are debonded steel bars to keep the slab in position in the axis perpendicular to the movement of expansion and contraction. Sealant, which is a compressive material into the top of the joint to prevent ingress of liquids. Compressive filler, to fill space between the two slab parts which would otherwise be filled by debris or sand, thus interfering with the slab movement. Expansion cap, tubular space to allow movement of the dowel. Reinforcement is discontinued at the expansion joint. Curing slab. Curing concrete is the process of protecting the concrete from moisture loss and maintaining its temperature at a suitable level for hydration, i.e. chemical reactions. In the process, the concrete is prevented from premature drying out as a result of wind or high temperatures. After 24 hours from casting, the slab is covered with a layer of sand and sprayed periodically with water to keep the sand moist in warm or hot weather for 7 days. The concrete slab is covered with waterproof or plastic sheeting firmly anchored at edges in rainy weather. The sheeting should be removed after the rains have stopped. The covering is meant to protect the fresh concrete within the first 24 hours. Further information can be accessed in a book I have published available on Amazon entitled Building Construction Supervision.